Hey everybody, this video is for lesson 7-1 as we begin chapter 7, and I am going to do a video on this whole lesson and you will have homework on it, and then we will be ready to start lesson 7-2 in class. So if you'll read along with me in your book, I'm on page 454. The Lord of the Rings movie transports viewers to the fantasy world of Middle-earth. Many scenes feature vast fortresses, sprawling cities, and bottomless mines. To film these images, the movie makers use ratios to help them build highly detailed miniature models. So we're going to be learning about ratios and proportions in this lesson. Let's start by talking about what a ratio is. And let me see if I can get my phone set up well to do that. A ratio compares two numbers by division. In other words, we write it oftentimes as a fraction. The ratio of two numbers A and B can be written as A to B, A colon B, or A over B, where B is not equal to 0. For example, the ratios 1 to 2, 1 colon 2, which is still 1 to 2, or 1 over 2, which is still 1 to 2, all represent the same comparison. Let's look at example 1, writing ratios. Let's read the remember text off to the side. In a ratio, the denominator of a fraction cannot be 0 because division by 0 is undefined. You may remember that from when we were graphing lines as well. All right, writing ratios. Example 1. Write a ratio expressing the slope of L. Let's come over here and look at our little graph. We want to write a ratio expressing the slope of L. Well, you know that slope is equal to y2 minus y1 over x2 minus x1. There we have a ratio of y2 minus y1 to x2 minus x1. So let's fill in our numbers. We would say y2, which of course could be either of these as long as we go in the same direction with the x's, but I'll start with 3. So we'll say 3 minus negative 1, which is going to be 3 plus 1, over 4 minus negative 2, which is going to be 4 plus 2. And our ratio is going to be 4 over 6, but we always want to present our ratio in lowest terms. So we can reduce this to 2/3. I'm kind of writing in the curve of the book, but I think you can still see that. All right, so let's check and make sure that our answer matches theirs, and it does. We always simplify our ratio to the lowest terms. All right, now let's do another one. Check it out. Given that 2 points on M are C and D, write a ratio expressing the slope of M. Well, you will see that I've already done the work for this. Our ratio is going to be the rise over the run, which slope always is. And I have M equals, and then I'm going to take y2 minus y1 over x2 minus x1, which really becomes 6 plus 2. And I get 2/8, and I reduce it to 1/4, and that is the final reduced ratio expressing the slope of line M that has those 2 points. All right, now let's move on to the next part of the lesson. A ratio can actually involve more than 2 numbers. For the rectangle, off to the side right there, the ratio of the side lengths may be written as 3 to 7 to 3 to 7, which you can see in the rectangle. The example, I'm going to need to move the camera. Give me just a minute. The example asks us to use a ratio, and it tells us the ratio of the side lengths of the quadrilateral is 2 to 3 to 5 to 7, and its perimeter is 85 feet. So we have 2 to 3 to 5 to 7. That doesn't mean that those are the lengths. You need to remember that. Those are not lengths that were given necessarily. That's the ratio of the lengths. It's the numbers that represent the ratio of their distances one to another. So 2 to 3 to 5 to 7. The perimeter of this quadrilateral is 85. What is the length of the longest side? Well, because each of these represents a ratio and not a length, we need to have a constant that allows us to figure out this problem. I'm going to say that our constant is x, the constant side length is x, and one of them is going to be 2x, one is going to be 3x, one is going to be 5x, and one is going to be 7x. So come look at this quadrilateral that I drew. A ratio of 2x, 3x, 5x, 7x, and the perimeter is 85. I am simply going to add up all of those sides now and set them equal to 85. I'm going to solve for x. 85 divided by 17 is 5. And now I have what x equals. The question asks me to find the longest side of this quadrilateral. Well, of course, that's going to be the 7x, not the 2, 3, or 5x. So 7 times 5 is 35, and 35 feet will be our longest side. All right, we have one more. We have a check it out problem to go with that part of the lesson. The ratio of the angle measures in a triangle is 1 to 6 to 13. You can see that I've drawn that in this triangle, 1 to 6 to 13. I've also, again, found a constant, which is my variable x, that will be true for every angle of this triangle, so that it's x times 1 is what this angle is, x times 6 is the second angle, and x times 13 is the third angle. Well, we know by the triangle sum theorem that all these angles must add up to equal 180. So I'm going to do just that. I'm going to add them up to equal 180. 1x plus 6x plus 13x equals 180. I'm going to solve for x, and x equals 9. Now I can plug 9 back in. And the question asks for the measure of each angle. So I had to multiply 9 by each number in the ratio, and I got 1x is equal to 9, 6x is equal to 54, and 13x is equal to 117. All right, I will end that video there, and you can stay tuned for the second video.